Right. I can say that the total week, whatever that I am discussing, they are totally on the basis of either equation of continuity or Bernoulli equation. Now let us start first with determination of rate of flow, and this is Venturi meter. This is called a Venturi meter. The Venturi meter is a device that you can see now, whatever that I am displaying on the screen, this part. That is Venturi meter. You will basically use this in canals and all that to determine the rate of flow. For example, you will go through sometimes in news in Q6 entry of the in Q6 వదిలేస్తున్నారని ఆ రేట్ ఆఫ్ ఫ్లో ఎలా తెలుస్తుందంటే ఇలాంటి ఇన్స్ట్రుమెంట్స్ ద్వారానే తెలుస్తుంది. So in this, what will happen is, in the direction of the flow, you will set this horizontal. Remember, at this point, cross section is high. At this point, cross section is low. And at this point, velocity of flow is V1. At this point, velocity of flow is V2. If you draw the streamline structure here, for example, the streamline structure will be like this. See, the streamlines are widely spaced. At this point, streamlines are crowded. Anytime you observe such a phenomena, this represents region of high velocity. And this one represents region of low velocity. మీకు నేను అసైన్మెంట్ పెట్టేసి అది చూసుకున్నారా రాత్రి మీరు వర్క్ స్టార్ట్ చేసేసుకోండి. రీజియన్ ఆఫ్ లో వెలాసిటీ, రీజియన్ ఆఫ్ హై వెలాసిటీ. Any doubt till this point? Right. Now the question is, you know, this is high velocity point, low velocity point, and this is high velocity point. So some form of energy in this zone need to be converted to some other form here, yes or no? What according to you? Here we are very clear, this is horizontal. No, there is nothing to question related to what you call gravitation part. But what form of energy is high here when compared to here? I can say different way. Here kinetic energy per unit volume is less when compared to the kinetic energy per unit volume here. In what terms you will see high factor over here? Pressure, obviously. So this region must be high pressure region and this region must be low pressure. But how can I measure that pressure difference? For this purpose only, you will have these vertical tubes. You see, in this tube, this liquid is static. This liquid is static. Rest, the entire thing is flowing. They are static. Why they are static? To maintain the pressure, they are static. Right. Now, I will define this as point A and I will define this as point B. At this point, PA plus half rho VA square is equal to PB plus half rho VB square. PA minus PB is half rho V2 square minus V1 square. Okay. Next. PA is equal to half rho VA square, PB plus half rho VB square. PA minus PB is half rho V2 square minus V1 square. PA minus PB is the pressure difference across these 2 points, which is nothing but rho. How you know these 2 points? Last week we have studied the pressure difference across these 2 points is same as the pressure difference across these 2 points with a static liquid. Yes or no? And what is that? Rho G delta H. So rho G delta H is equal to half rho V2 square minus V1 square. Don't forget what is the rate of flow. A into V is called rate of flow. dm by dt is not rate of flow. It is mass entering per second or mass leaving per second. But A into V is called rate of flow or volume entering per second or volume leaving per second. That is called rate of flow. So as per Bernoulli equation of continuity, you can write A1 V1 is equal to A2 VT is equal to V. Don't forget why I am doing all this is to find the expression for rate of flow. So I am eliminating V1 term, V2 term here with the rate of flow term. Done. So finally, I will get rate of flow as 2G delta H A1 square A2 square by A1 square minus A2 square. Lot of students will have a feel, is this venturi meter applicable only for liquids? Wrong. You can use this for gases also. But when you are using gas, you will use a mercury for comparison. Okay. Now you see how it is affected in mercury. Now you can see that gas is rushing out like this. You want to find the pressure difference at these 2 points. You can use this. Or if you want to find the rate of flow of the gas, you can use this instrument. But you require mercury for this. Now see, try to please understand, as I mentioned earlier, here velocity is low. Here the velocity is high. From here to here, some form of energy need to be converted to some other form. So, air gravity is nothing for gas. This is high pressure, this is low pressure. And now the question is high pressure, low pressure. So therefore, at this point, pressure is the same as at this, because this is a static liquid. Right. So at this point, pressure is the same. Now therefore, for across this, what is the pressure difference? Rho GH. Yes or no? And that same relation, right? I have used the same relation here. Rho place rho mercury, G place G, delta H, half. But rho equivalent liquid. But ikkada rho air. So then you will have the relation here. Remember, this is for liquid and this is for gas. Don't get confused between these two. Don't get confused between these two. Right. Next. The next part deals like this. There is another application, but don't forget this. Where streamlines are crowded, velocity is high. Where streamlines are spread, velocity is low. Similarly, this is a high pressure region and this is low pressure region. Don't ever get confused. But no two streamlines intersect. Please remember. If they intersect, it is not streamline flow. Such a flow will be turbulent. No two streamlines will intersect. Okay? So where they are crowded, pressure is high. Velocity is high, pressure is low. Where they are spread, velocity is low, pressure is high. Torricelli's theorem. And simple form of Torricelli's theorem is first time introduced. In a simple form of Torricelli's theorem, what you will have is a container with a small hole. This area of cross section is a much higher than the hole which I have created. Now you take one fluid element which is flowing along this path. This is called streamline. Now please try to understand, when this fluid element is here, it has rho GH, and almost very slowly, infinite slowly, the level will fall. So the velocity of that can be negligible. Remember, this is true when this is the condition. I'll just give you a simple reason. మీ ఇంట్లో డ్రమ్ ఉంది, డ్రమ్లో నీళ్లు పెట్టారు, చాలా చిన్న లీకేజ్ ఉంది. మీరు చూస్తున్నంతసేపు లెవెల్ బాగానే ఉంటుంది. మీరు రాత్రి చూసినప్పుడు ఫుల్ లెవెల్ ఉంటుంది, మార్నింగ్ చూస్తే హాఫ్ ద లెవెల్ పడిపోతుంది. అంటే ఒక ఫుల్ నైట్లో అది ఎంత, ఒక ఉదాహరణకి హైట్ ఒక 30 సెంటీమీటర్స్ టోటల్ హైట్ ఉందనుకోండి, 15 సెంటీమీటర్స్ ఒక నైట్లో పడిపోయిందంటే దాని స్పీడ్ ఏ చెప్తారు చెప్పండి? రాత్రి మొత్తం కలిపి అంటే ఒక 10 hours డ్యూరేషన్లో అది ఎంత ట్రావెల్ చేసింది? 15 సెంటీమీటర్స్ ట్రావెల్ చేసింది. అంటే ఆల్మోస్ట్ ఆ స్పీడ్ నెగ్లిజిబుల్. కాబట్టి ఇక్కడ 0 వేస్తాను, లేకపోతే అది కూడా రాయాలి. అదే మీరు ఒక పెప్సీ బాటిల్ లాంటిది తీసుకుని దానికి చిన్న హోల్ పెట్టాను అనుకోండి, మీరు చూస్తుండగానే లెవెల్ టక్ 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 పడిపోతుంది. అప్పుడు ఆ 0 వేయకూడదు, ఇక్కడ 0 వేయకూడదు. అండ్ ఇది ఫ్రీ కాబట్టి ప్రెషర్ 0, కైనెటిక్ ఎనర్జీ 0. ఇక్కడికి వచ్చారనుకోండి, ఇక్కడికి వచ్చేసేటప్పటికే అఫ్ కోర్స్ యాక్చువల్గా ఇక్కడ P0 కూడా వేయాలి, ఇక్కడ కూడా P0 ప్లస్ అని వేయాలి. ఎలాగో కొట్టేసేవి, ఎందుకు వేయటం? కాబట్టి ఇక్కడ ప్రెషర్ ఎంతో ఇక్కడ ప్రెషర్ కూడా అంతే, అట్మాస్ఫియరిక్ ప్రెషర్. కాబట్టి నేను కన్సిడర్ చేయాలి. సో దేర్ ఫార్ rho GH is equal to half rho V square. According to, this is according to Bernoulli's equation. So V is equal to root 2 GH. This velocity is called velocity of flux. But remember, while the flow ejects out, it is like something that comes out of the middle. మీరు ఎప్పుడైనా ఫైర్ ఫైటర్స్ చూసినట్లయితే వాళ్ళు చాలా గట్టిగా పట్టుకోవాల్సి వస్తుంది ఆ నాజిల్ని. ఎందుకు? ఈ పోయే జెట్ వెనక థ్రస్ట్ ఫోర్స్ ఇస్తుంది, ఆడు కదిలిపోతాడు. కాబట్టి వాడు చాలా సాలిడ్గా పట్టుకుంటాడు ఆ నాజిల్ని. సో కాబట్టి ఇక్కడ మీరు నోటీస్ చేసినట్లయితే, మామూలు సిస్టమ్ ఆఫ్ వేరియబుల్ మాస్ చెప్పినప్పుడు నేను మీకు చెప్పాను, రాకెట్ నుంచి ఎగ్జాస్ట్ గ్యాస్ బయటకు వస్తూ ఉంటే ఎగ్జాస్ట్ గ్యాస్ ఎగ్జాక్ట్ చేసే థ్రస్ట్ ఫోర్స్ ఫార్ములా U relative into dm/dt. అవును, విత్ రెస్పెక్ట్ టు ద కంటైనర్ వాటర్ ఈజ్ ఫ్లోయింగ్ అవుట్ విత్ దిస్ వెలాసిటీ, అండ్ dm/dt అంటే రేట్ ఆఫ్ ఫ్లోలో ఒక పార్ట్ రో AB. టోటల్గా AB² రో వస్తుంది. అంటే ఈ ఫార్మాట్ లో ఇలా బయటికి వెళ్ళేటువంటి లిక్విడ్ కంటైనర్ మీద ఎగ్జర్ట్ చేసే ఫోర్స్ AB² rho. That is called the thrust force of the exiting liquid on the container. Any doubt on this? Sure, every student in the class. సిస్టమ్ ఆఫ్ వేరియబుల్ మాస్ లో రాకెట్ కి వేసావు, ఇది గుర్తుందా లేదా? ఎగ్జాస్ట్ గ్యాస్ విత్ రెస్పెక్ట్ టు ద రాకెట్ U relative తో వెనక్కి వెళ్తే ఎగ్జాస్ట్ గ్యాస్ రాకెట్ మీద ఎగ్జర్ట్ చేసే ఫోర్స్ కి ఎక్స్ప్రెషన్ ఇచ్చాను, U relative into dm/dt. సిస్టమ్ ఆఫ్ వేరియబుల్ మాస్ లో చెప్పాను నేను. ఓకేనా? రైట్. అలా కాదు, సారీ, ఏ గ్రేటర్ దాన్ ఏనే స్టిల్ బట్ నాట్ మీరు చెప్పినంత కాదు, అప్పుడు ఈ ఈక్వేషన్ లో చేంజ్ వస్తుంది. ఇలా రాయిపోతుంది. అప్పుడు ఏమవుతుంది? ఎట్ అన్ ఇన్స్టెంట్ దీని హైట్ హెచ్ అనుకోండి, మైనస్ డిహెచ్ బై డిటి రేట్ ఆఫ్ ఫాల్. అంటే ఒక రకంగా చెప్పాలంటే ఇక్కడ ఉన్న ఫ్లూయిడ్ ఎలిమెంట్ వెలాసిటీ మైనస్ డిహెచ్ బై డిటి ఇంటూ ఏ ఈజ్ ఈక్వల్ టు ఇక్కడ ఉన్న ఫ్లూయిడ్ ఎలిమెంటే కదా ఇటు వచ్చేది అని అనుకుంటే, ఇక్కడికి వచ్చేటప్పుడు ఆ ఫ్లూయిడ్ ఎలిమెంట్ వెలాసిటీ ఎంత? బి. రైట్, ఇది ఈక్వేషన్ ఆఫ్ కంటిన్యూటీ. గుర్తుపెట్టుకోండి, ఇందాక అసలు ఈక్వేషన్ ఆఫ్ కంటిన్యూటీ వార్ల ఓన్లీ బెర్నౌలీస్ ఈక్వేషన్స్. ఇప్పుడు ఐఎమ్ యూజింగ్ ఈక్వేషన్ ఆఫ్ కంటిన్యూటీ. అలానే ఫార్మ్స్ ఆఫ్ ఎనర్జీ చూసుకోండి. ఇందాక ఇక్కడ ఫ్లూయిడ్ ఎలిమెంట్ ఓన్లీ రోజీ హెచ్, ఇప్పుడు రోజీ హెచ్ ప్లస్ హాఫ్ రో వి స్క్వేర్ ఈజ్ ఈక్వల్ టు హాఫ్ రో వి స్క్వేర్. ఈ టర్మ్ ఒకటి యాడ్ అయింది, ఇది యాడ్ అయింది కాబట్టి ఇది డిస్కస్ చేశారు. ఈ రెండు స్టెప్స్ నాకు ఒకసారి కన్ఫర్మేషన్ ఇవ్వండి. తప్పండి. హ్యావ్ యూ అండర్స్టూడ్ దోస్ టూ స్టెప్స్ క్లియర్లీ? Everyone in the class, everyone in the class, please see that. Have you understood it or not? Additionally, you have this term. Additionally, you have this term. So, rho GH plus half rho. This term, this को चेक substitute this. Half rho this. ये वस्तु rho GH is equal to half rho V square times 1 minus a square by a square. ఈసారి వెలాసిటీ ఆఫ్ ఎఫ్ ఫ్లక్స్ ఇట్లా రాయటానికి లేదు, యాక్చువల్గా ఇలా రాయాలి. ఇంకో విషయం చెప్పనా, ఇదే ఎప్పుడు మీరే చెప్పండి. ఏ వెరీ వెరీ స్మాల్ వెన్ కంపేర్ టు ఏ అయినప్పుడు 1 minus a square by ఏమవుతుంది? ఆల్మోస్ట్ 1 అయిపోతుంది. రైట్, నాకు ఒక్కసారి రెండు కన్ఫర్మేషన్ ఇవ్వాలి. See, unlike previous chapters, this chapter I am giving complete theory on first day. Because majority 50% of the problems can be done by yourselves. This week assignment I have given 100 questions, literally 100 questions I have given. So you need to start parallelly that assignment also. Right, next. Okay, ఒక్కోసారి మిమ్మల్ని టైం కూడా అడుగుతారండి, ఎంత టైం పడుతుంది అది కూడా అడుగుతారు. సో హియర్ యూ హ్యావ్ వాట్ యు కాల్ ద డ్రమ్ లైక్ అరేంజ్మెంట్ at a height h hole. Let us assume that this is the given condition to you. You can still apply equation of continuity. You can still apply equation of continuity, but remember here I have used root 2gh. Why? This is the condition. So minus dh by root 2gh is equal to, this is the condition. Any doubt till this step? Everyone in the class. అమ్మాయి ఇవాళ వచ్చిన అమ్మాయి సుదీక్ష, నీకు రైట్ హ్యాండ్ శృతి అని పేరు, అర్థమవుతుందా నీకు? ఫాస్ట్గా వెళ్తున్నానా? రైట్, ఇది సిచ్యువేషన్. నేను ఎందుకంటే నోట్స్లు తెచ్చుకోమనేది కదా. ఏం చేస్తారు ఇప్పుడు? లిమిట్స్ పెట్టి ఇంటిగ్రేషన్ చేస్తారు. నువ్వు చూసినప్పుడు t is equal to 0, హైట్ h1, కొంతసేపటికి హైట్ h2, ఎంతసేపటికి h2 అయింది h1 నుంచి. ఇదిగో ఇంటిగ్రేషన్ స్టెప్. దీస్ ఆర్ ఆల్ వెరీ 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 ఇంపార్టెంట్. ఎనీ డౌట్ ఆన్ దిస్? Everyone in the class, I'm asking again. Everyone. Rashmika, Rakshita. Follow. Right. Next. అన్విత్ రాలేదు ఇవాళ. మరి ఎవరు ఇద్దరు రాలేదా? సాత్విక్ రాలా, సాత్విక్ ఒక్కడే రాలా, నిన్న కూడా రాలేదు వాడు. ఏమొచ్చింది అమ్మాయి రాలా. నెక్స్ట్, now you see a container like this. You have a container. In the container, water is till some capital H, and there is a hole at a depth h below. The water comes out of this hole. At this point, velocity is root 2gh. V is equal to root 2gh. Right. Now, please try. I'm just again taking again. I don't get confused again. I'm taking this as A much greater than small a. Now, please try to understand what is happening over here. This part of the liquid that comes out is with V is equal to root 2 GH. But it is still at a height capital H minus small h. So, what is the expression for range? The expression for range is root 2 GH times under root 2 times H minus small h. So, range is 2 times root H into capital H. It's a function of small h. It's a function of small h. dr by dh is equal to 0. For what? To have maximum. Because when r is a function of small h, for r to have maximum value, what we will do in mathematics? dr by dh is equal to 0. By doing which, you will get this relation. నేనేమే మోసం పెట్టాలా? ఈ ప్రోడక్ట్ maximum value రావాలి అంటే దీని డిఫరెన్షియేషన్ h minus h minus h times minus 1 is equal to 0. అంతే కదా? It is okay. So till this point, so you are speaking now about another application of Bernoulli's equation. This is a working of siphon. You know, number of times you would have seen in your childhood emptying a container. We are emptying a bike, petrol, transferring petrol from one bike to another bike. All these are the siphon principle. See, mostly in majority of the occasions, the tube which we are using for siphon is a constant cross-sectional area from one end to other. So long the cross-sectional area is a constant, the rate of flow, the velocity of flow is also constant. The velocity of flow is also constant. So now what happens? Let us see here. See, I am assuming that at this point A, it is open to air, atmospheric pressure, and flow is almost zero, that point. But inside the tube, even though it is the same horizontal pressure is not the same because there is a flow. So it's a low pressure point when compared to A. As it goes up to C, the pressure further falls because there is a gain in gravitational potential energy without any gain in kinetic energy. So something is to loss, pressure energy is lost. Again, entire CD level pressure is the same. And again, the fluid comes down. By the time it reaches E, it will have the same pressure as that what it would have at A. Any doubt till this point? Are we clear? Right. Now, try to please understand energy at A, energy at B, energy at C, energy at D, energy at E is the same. Right. Now, energy at A, it's simply atmospheric pressure. Energy at B, pressure energy plus kinetic energy. Energy at C, pressure energy, kinetic energy, gravitational potential energy. Energy at D, pressure energy, kinetic energy. Remember, pressure at C, pressure at D. I am not writing two different terms. Remember, this I am writing for both the C and D. But both the C and D, it is the same term because same horizontal level, same flow, same height, same pressure. So by the time it reaches P naught, by the time it reaches E at this point, E, P naught, half rho V square. Remember, I took this level as 0. Anything above is a plus H for me. Anything below is a minus H for me. అంతే కదా. ఇప్పుడు ఎంజీహెచ్ అంటే ఏంటి? ఏదో ఒకటి జీరో చేసుకుని కదా మీరు చెప్పేది. ఐ టుక్ దిస్ లెవెల్ యాజ్ జీరో. అబౌట్ దిస్ లెవెల్ ఇట్ ఈస్ ఎంజీహెచ్, బిలో దిస్ లెవెల్ ఈజ్ మైనస్ ఎంజీహెచ్, మైనస్ రోజీహెచ్. మీరు ఈ సైఫన్ లో ఏమైనా డౌట్ ఉంటే ఈ స్టెప్ డౌట్ ఉండాలి. ఒక్కసారి అంతా మళ్ళా చూసుకోండి, స్టెప్స్ అంతా ఒకసారి చూసుకోండి. ఏ దగ్గర క్లియరా, బి దగ్గర క్లియరా, సి దగ్గర క్లియరా, డి దగ్గర క్లియరా, ఈ దగ్గర క్లియరా? ఎనీ డౌట్? రక్షిత ఏమైనా డౌట్ ఉందా? చివరమ్మాయి నీ పేరు మర్చిపోయాను. శ్రేయశ్రీ, ఏమైనా డౌట్ ఉందా? రైట్. అరే మీరు రా వరుణ్, ఎనీ డౌట్స్? శ్రీమాన్, శ్రీమాన్ వీడా, శ్రీమాన్ ఎనీ డౌట్? రోహిత్, అన్విత్ ఎనీ డౌట్? అన్వేష్ ఆవిడ ఎనీ డౌట్? షూర్రా? రైట్. రుత్విక్ ఏం చేస్తారు? ఈక్వేషన్స్ దగ్గర పెట్టుకుంటాను ఫస్ట్. ఐ విల్ ట్రై టు కంపేర్ దీస్ టూ ఈక్వేషన్స్ ఫస్ట్. These two equations. When I am trying to compare these two equations, what is happening? PC plus half rho v square plus rho g h1 is P naught plus half rho v square minus rho g h2. PC దగ్గర lowest pressure కదా, out of all. Pressure will be lowest at C or D when compared to any other points. When compared to any other point, pressure will be lowest. Right. Till this, do you have any doubt, students? Anyone having doubt till this point? Now what I am going to do right now is PC plus half rho v square plus rho g h, this step equals to this step. So in this case, this must be greater than or equal to 0, which means P naught minus rho g h2 plus h1 greater than or equal to 0. For siphon to work, condition for working of siphon. For example, if you took h1 plus h2 more than P naught by rho g, it won't work. If we have h1 plus h2 less than P naught by rho g, not an issue at all. That will work, no issue. But it should not be greater than P naught by rho g. At 10 meters and 10, roughly 10 meters. Atmospheric pressure 10 power 3 and 10 power 5. వాటర్ తీసుకున్నారు అనుకోండి, రో 10 power 3, జీ 10, అంటే అప్రాక్సిమేట్ గా పీ నాట్ బై రోజు ఎంత కావాలి? 10 meters. 10 meters మామూలు విషయం కాదు. 10 meters ఈజ్ ఏ లాంగర్ లెంగ్త్. అంటే ఇప్పుడు 10 meters అంటే ఇప్పుడు మనం ఉన్న రూమ్ ఉంది, మనం ఉన్న రూమ్ బాటమ్ టు టాప్ ఎంత ఉంటుందని మీ ఉద్దేశం? 10 feet ఉంటుంది, రఫ్లీ 10 to 11 feet ఉంటుంది. ఈ పాత బిల్డింగ్స్ కాబట్టి, అవునా? నియర్లీ ఒక ఫీట్ అంటే రఫ్లీ 30 centimeters దాకా వర్కౌట్ వస్తుంది. 30 centimeters దాకా వర్కౌట్ అవుతుంది. సో కాబట్టి 10 అంటే ఎంత? 3 meters, 3.5 meters కన్నా తక్కువ ఉంటుంది ఒక ఫ్లోర్. సో అలాంటివి 2 to 3 floors మీరు చెప్పారు. నియర్లీ 10 meters is a big length. రైట్. ఇప్పుడు ఏ తీసుకోండి, ఈ తీసుకోండి, మళ్ళీ చెప్తున్నా. ఏ పాయింట్, ఈ పాయింట్ తీసుకోండి. A దగ్గర atmospheric pressure, E దగ్గర atmospheric pressure plus rho g H2 plus half rho v square. ఇక్కడ మైనస్ సైన్ ఉండాలి, ఉంది మైనస్ సైన్, అదిగో మైనస్ సైన్. So therefore finally the velocity through which the fluid flows through the siphon depends only on this level difference, irrespective of that level. It strictly depends on only this level difference. అందుకని కండిషన్ ఏంటి? ఈ ఎండ్ ఎప్పుడు దీనికన్నా కింద ఉండాలి. ఈ ఎండ్ కనుక ఇక్కడికి వచ్చింది అనుకోండి, సైఫన్ వర్క్ చేయదు. సైఫన్ విల్ నాట్ వర్క్. కంపల్సరీలీ ఈ ఎండ్ కన్నా కింద ఉండాలి. కంపల్సరీలీ దిస్ ఎండ్ మస్ట్ బి బిలో దిస్ ఎండ్ ఫర్ సైఫన్ టు వర్క్. Therefore V is equal to root 2GH2. This is also one of the emphases. Now what will happen in this chapter? You will simply substitute contents. So siphon is one important application related to this. Next, pitot tube working principle. This is also one of the applications where you will use to determine the velocity of flow in a liquid. It is like it's like a J-type bent tube. J axon la undi zonandi the call system. So the lowest is horizontal, the upper part is vertical. Now I have inserted this in the flow. Now the liquid flows like this. Now try to please understand one fluid element which enters here travels till this point. One fluid element enters here, travel till this point. While entering, it has a KE per unit volume. While reaching here, gravitational potential energy per unit volume. So velocity is root 2GH. Suppose if the tube is not sufficient length, for example, H unte okay, H kalla takku unte avuthundi. But meeku ardham kaala. Indulo tube length ikkada daaka undi, liquid stopped here. Suppose if the tube length is lesser than that, lesser than H, then what happens? By the time it reaches here, it will still have some velocity. Then how you will apply the relation? You will apply the relation like this. That is pitot tube. Any doubts? Boys and girls. Sushmita, Palainattena, Anika. Next. From here, it is a totally numericals. All these are numericals. Simply numericals. Right. So first theory is important. So I have tried all the theory points. It's a very, very, very famous model. Really very famous model. So please go through this question carefully. What work to be done in order to squeeze all water from a horizontally located cylinder during the time t by means of a constant force acting on the piston? The volume of the water in the cylinder is equal to V. The cross-sectional area there it is, yes, orifice is A. Okay. Read the question carefully first. Now the issue is that now please try to understand what is happening over here. What is happening over here? Now please try to understand at this point what is the pressure. The pressure here is atmospheric pressure plus additionally you are applying that pressure. Mostly the entire container, the pressure part is the same. Because you are taking the cross-sectional area A much greater than S. Okay. So at that point also, at this point also, pressure will be P1. Apply Bernoulli's equation. P1 is equal to any doubt in this equation? Which means P naught plus F by A is F by A is half rho V square. Now I clearly got an idea about F. Right. See, please try to understand. Let the time taken to empty V volume of liquid B T. Remember, both are given in the question. Yes or no? Both were given in the question. So what is the rate of flow? Rate of flow is V by T, which is equal to SV. Yes or no? V by T is equal to S. V is nothing but 2F by rho A. Okay. So, oh, sorry. What is that they want actually? What is that they want? Work done. Okay, Kanisha. So now I have a clear-cut idea about F squaring on both the sides. That is F. Right. So F, I got a clarity now. What is the work done by this force? So let us assume that this is of length L. Okay, that is of length L. F is equal, W is equal to F into L. F into V by A. Therefore, finally, F by A can be written as rho V cube by 2T square S square. Boys and girls, this is a very, very, very important question. A lot of times you will face such questions. Equation of continuity based. Any doubts? Right. Next. So this is one of the applications of Bernoulli's equation. So this is working of painting and Bernoulli working of paint gun. It is on the basis of Bernoulli's equation. This is on the basis of Bernoulli's equation. Right. Now let us see how this works. You are creating a pressure difference by maintaining the flow of the air above this. What actually happening is in this T tube, by blowing air, we are creating low pressure here. When compared to the point here, this will become high pressure. Of course, that is atmospheric pressure, undoubtedly. So now what is happening in this is that now try to see two regions here. Region 1, region 2, and region 3, which I will show it like this. This is region 2 and this is region 3, which is your liquid. Now what is happening here across 1 and 2, P1 minus P2 is half rho air V air square. Please say yes or no for this. Just now we have done this question. Everyone in this class, please respond this. P1 minus P2 is half rho air V air square. Till this point very clear? Baga Jolandi 1, 2, 3. Everyone on the board. Next again P3 minus P2, because I said the air that passes through the nozzle creates a low pressure at 2 than that at 3. That is how system works. Then what happens in this case is half rho liquid V liquid square. Any doubts? Boys and girls? Next. Don't ever forget that here P3 is the same as P1. Yes or no? Okay. Here P3 is same as P1. Both the is atmospheric pressure. atmospheric pressure. Now, what is happening from these two equations is that rho air, V air square is rho liquid, V liquid square. So therefore, what you want in the question, then for a given piston speed, liquid sprayed, V liquid is rho air by rho liquid under root V air. So what is your answer? Rho air by rho liquid. So this is the working principle of paint gun. Any doubt, please ask me. Boys and girls. If you have any doubt, please ask me. So Bernoulli's equation, a part of the Bernoulli's equation I have answered right now. Next. AC. Second. A horizontal oriented tube AB of length 5 meter rotates with a constant angular velocity of 0.5 radian per second. About omega is 0.5 radian per second. It's about a stationary vertical axis oval dash that passes through the end A. The tube is filled with ideal fluid. The end A of the tube is open. This is open. Means here the pressure is atmospheric pressure. The velocity with which the liquid comes out of the hole is. First of all, assume that there is no hole there. Now let us see pressure at that point. We already know. Last week only we have done this. Suppose if this is how the liquid is rotating, so at a point, the pressure difference delta P into cross-sectional area S supplies the necessary centripetal force for the one which is rotating, rho S dx m x omega square. Agreed? Now do the integration properly. Now here at x is equal to x1, pressure is P naught at some x. Let the pressure be P. So yes, you can cancel. P minus P naught is equal to half rho omega square x square minus x1 square. Right. Now at this point, the pressure is P1 given as P naught plus half rho omega square. Can you please help me? X1 is 3, X is 5. Yes or no? Which means 5 square minus 3 square. This is the pressure at this point. And outside, it is kinetic energy. So apply Bernoulli's equation. P1 plus 0 is equal to P naught plus half rho V square, which implies P naught plus half rho omega square 4 square is P naught plus half rho V square. Velocity is equal to omega square 4 square. Omega times 4. Half 4 2 meters per second. Any doubts? It's a standard question. Even we have this in what do you call period. Any doubts? I'm just applying equation of continuity. Just applying equation of continuity. Right. I'll deal some more theory now again. Some more theory. And that theory is applications of, see, almost by today I'm closing the entire theory for this week. The Bernoulli's equation, one application I have shown right now. What is that application? Paint gun. The other is, you will see that in aeroplanes, aerodynamic link. You can see the wings of the aeroplane are like the wings of the bird. For the aerodynamic structure, it is designed like that. What is happening? I'll try to explain. You will see when the aeroplane is moving, you can see the streamlines of air around the wings, above and below, basically. You can see the streamlines here, above and below. What is that you have noticed? Can you please explain? Above and below. What is that you have noticed? Where it is crowded more, above. So pressure is low there. Where it is spread below, pressure is high. So therefore, for an aerofoil, what is that you will call as aerofoil? A term called aerofoil is used to describe the cross-sectional shape of the objects such as aeroplane wings. Aeroplane wings are called aerofoil. Now the aeroplane is moving leftwards. This is moving like this. It feels that the air passing above, or with respect to me, the streamlines will pass through right because I am moving leftwards. But the structuring of the aerofoil is such that the streamlines will be crowded above, spread below. Low pressure above, high pressure below. Now this gives me a pressure difference in the vertical direction upwards. And that supports the weight force. Okay? So therefore, this is on the principle of Bernoulli's equation. Now, for example, what is that you will use is P2 plus half rho V2 square is equal to P1 plus half rho V1 square. Since V2 is less than V1, the pressure difference can be written as half rho V1 square minus V2 square. This should be greater than or equal to the weight by cross-sectional area of the airplane. That is the working principle of aeroplane. So where you used Bernoulli's equation, have you understood? Are we clear? Everyone in this class? Right. Next point is Magnus effect. Ikkada sprayer kuda ichchanu, but still Magnus effect. You see a non-rotating ball moving leftwards. So for me, the streamlines above and below are equally spaced. So no pressure difference in the vertical direction. Now what I am doing is, I am throwing the ball leftwards with a spin. When I am seeing this, I see a clockwise spin traveling leftwards. The effect of this is above drag is high when compared to below. You see, above the streamlines are crowded because of the spin when compared to below. So this gives a lift to the ball which is not expected by the batsman. Ide meeku ee spin valla ravalsina height kanna koddiga ekku height veltundi. And this principle, this effect is called Magnus effect. For a rapidly spinning ball, you are seeing the situation again. And again, this follows from Bernoulli's equation. And this principle is Magnus effect. Okay, na? అలానే ఇందాక ఆల్రెడీ చెప్పాను స్ప్రేయర్ వర్కింగ్ ప్రిన్సిపల్ ఆఫ్ స్ప్రేయర్ కూడా చెప్పాను. We are blowing air through this part air you are blowing through this path, air leaves like this, and this creates a low pressure at this point when compared to this point, so the liquid will rise up. Okay, na? So half rho air V square, just know, actually we are supposed to write this part also. This is what you need to write actually. I'm not cheating you, that's a fact. In fact, P3 minus P2 వేసేటప్పుడు మీరు ఏం రాయాలి? P3 is equal to P2 plus half rho L V liquid square plus rho L liquid GH కూడా రాయాలి యాక్చువల్ గా. స్మాల్ కాబట్టి నెగ్లెక్ట్ చేశాను అక్కడ నేను. If it is not small, a rho liquid V liquid square దగ్గర rho GH part కూడా రాయాలి. అది కూడా రాయాలి. జనరల్ గా ఇక్కడ ఏమవుతుందంటే mostly we will take V liquid square almost the same as V square. Mostly. Okay. But actual అయితే రూల్ ఇది. సో దీన్ని మనం ఏం చేస్తామంటే నియర్లీ మనం ఏం చేస్తామంటే ఇలా కూడా రాదు. So you need to decide this on the basis of the case. Okay, so that's all for today. Already the content is in your notes itself. So therefore, after 3 days, I'll post the notes. So that's all.